Now I'll try to explain what we mean by power. In the previous example, we defined what effect size is. And now, building a little bit on top of that intuition on effect size, we are talking a little bit about power. So here are two examples, one and two. The first example is where the hypothesis mean, a null hypothesis mean is 90, and the alternative hypothesis should find out from like real data set that actually the data mean, the sample data mean is 94. And we have here two distributions, one with the mean of 94 and one with the mean of 90. And we're trying to show here that if those two distributions have the same standard deviation, it actually happens quite often that we will conduct something called the type 2 error, where we actually derive the data from this distribution with mean 94, but it's somewhere over here in this area, which is not considered a significant difference because it falls outside this significant difference detection threshold. This is an issue. And now this is like, and here we can say that the effect size is relatively small. And now this is another example where the effect size is larger, where instead of this 94, the difference between the two data sets is 8. And you can see that the area where we actually get this data, or the alternative hypothesis data, actually it can come from here, and it's very rarely goes into the insignificant part of null hypothesis distribution. And this actually is the power that we have set. So usually this is set to be 80%. And we want this area here to be as big as possible so that we are able to detect this significant effect.